This is systematic procedures for drawing Lewis structures for covalent molecules. Lewis structures, also known as Lewis dot diagram, show bonding relationship between atoms of a molecule and the lone pairs of electrons in the molecule. And covalent bond is a bond formed when electrons are shared between two nonmetals. So before drawing the Lewis structure, we must know what valence electron is. So valence electron is the electron in the highest energy level, or the outermost energy level. And we can determine the valence electrons from main group elements, also known as representative elements. The main group elements are numbered from 1A, group 1A through 8A. The transition metals are not included here. So to figure out the number of valence electrons, we determine the group number of the element. If the element is in group 1A, then the element has one valence electron. So, like we see here, all the elements in group 1A has one valence electron. All the elements in group 2A, two valence electron. Up to group 8A, 8 valence electron, except helium that have 2 valence electrons. Then we also should know how to determine the electronegativity values of each element. The electronegativity values are below the symbol, okay? They're below the symbol, okay? The symbol of the element. Then this is step-by-step procedure. There are many ways of doing drawing Lewis structure. Some do it by trial and error, but this is step-by-step procedure. So the step 1 is determine the total number of valence electrons. For cations, subtract 1 electron for each positive ion. For anions, add 1 electron for each negative ion. Step 2, determine the central atom. If the compound contains carbon, the carbon must be the central atom. No other element can be that, because carbon has 4 unpaired electrons. Hydrogen can never be the central atom. Then look at the electronegativity value of each atom. The one that has the smallest electronegativity value is the one to be the central atom. And then also you can determine the central atom by checking the atom with the most unpaired electrons. Step 3, make the terminal atom stable. Make the terminal atom stable. For hydrogen, it needs only 2 to be stable. Then you make it stable, you make it octet by placing 8 electrons, if it's not hydrogen. Then place all remaining electrons on the central atom, if applicable. If central atom does not have an octet, move electrons from terminal or outer atoms to form double or triple bonds. Then step 5, check if each atom is octet. Circle each atom with all the electrons around it, includes lone pair and bonding electrons. Step 6, draw a structure with single bond, double bond, or triple bond. This single bond, we share 1 pair of electron, double bond, 2 pairs of electron, triple bond, 3 pairs of electron. These are the examples we have to do together. So we start with the first one. So the step 1 will be to calculate the total number of valence electrons. So we know carbon, 1 times 4 is 4. Hydrogen, there's 3 of them. 3 times 1 is 3. Iodine, 1 times 7 is 7. So carbon has 4 valence electrons, hydrogen 1 valence electron, iodine 7 valence electrons. So 14 valence electrons. Now, step 2 is to determine the central atom. Carbon is in this compass, so it's the central atom. Then we place terminal atoms. It doesn't matter where you put it. Then we make each of these outer atoms stable. Hydrogen needs to be stable. Iodine needs H to be stable. Then we check if each atom is stable. So the central atom can share with iodine, share with this hydrogen, share with this, share with this. So we do this to make sure or to show okay. So each atom here is stable. So we make it cleaner by showing the shared electron, which we use bond to show. We have carbon 1, some students forget that. This is Lewis dot structure for example 1, the first element. So we go ahead and do the second one. Example 2, again, we determine the total number of valence electrons. Sulfur has 6 valence electrons. Bromine has 7. So 2 times 7, there are 2 of them. So 14, total of 20 valence electrons. Now, which one should be in the middle? Sulfur, if we check has less electronegativity compared to bromine. So we have sulfur in the middle. So you should take out your electronegativity periodic table. So we have bromine here. Okay. So sulfur is the central. And another way in this particular case is to figure out, there are multiple ways of doing it. You can also figure out how many unpaired electrons sulfur has. Sulfur has 2 unpaired electrons. That's another way of knowing what will be in the middle. Bromine has 1 unpaired electron. That makes sulfur to be in the central atom. Now, we make the terminal atoms stable. This will be octet, is not hydrogen. This will be octet. Okay, we used total of 16 valence electron. So we have 4 remaining. So that 4 we put in the central atom. We put 1 here on the central atom. It has to be on the central atom. We cannot put it between these 2 on the central atom. Now, is each atom stable? We check. This is stable. This is stable. Has to be clean. This is stable. Now we'll show the shared electron by using bond. We want to make everything cleaner. They are single bond because only 2 electrons are being shared or 1 pair is being shared. So that's the Lewis dot structure. So we go to example 3. So example 3 is CO2. Step 1, determine the total number of valence electrons. Carbon, there's 1 carbon, times 4, that's 4. Oxygen, there are 2 of them, 2 times, it has 6 valence electrons, 12, so we have a total of 16 valence electrons. Now, because carbon is there, carbon is the central atom. Then we place this here. Then we make each of these terminal carbon octet. So we do that. We make this terminal carbon octet. Now, we run out of electron. There's nothing to put in the central atom. Central atom, if it shares with this, it shares with this, it doesn't have 8. So we have to use the electrons in the terminal carbon to make it octet by, and this will result to double bond. So we move this to here, we move this to here. You cannot watch rearranging the whole thing because the goal is to make the central atom octet. Now, let's see if that works. We do this. We do this. Do that. Now we have to show the shared electron. 2 pairs are being shared, so that's double bond. 2 pairs are being shared, so this is double bond. The same here. So that's the Lewis structure for CO2. So we go to example 4. Example 4, we have, again, calculate the total number of valence electrons. So phosphorus has 5 valence electrons. Chlorine, 3 times 7, 21, 5, 26 valence electron. Okay. Then electronegativity of phosphorus is less than that of Cl. So, but we can also do it this way. Which one has the most unpaired electron? Then we have chlorine has 1 unpaired electron, and phosphorus has 3 unpaired, so phosphorus also will be in the middle. So you choose how you want to do it. All of them are correct. Then you put the terminal atoms. Phosphorus is the central atom. So we make each of these stable. So we have 8, 8, 8, 24. We have 2 valence electron left. So they say we place it on the central atom. We place it on the central atom like that. Now, is this stable? 2, it shares with it, shared with it. Let's see. We draw. Draw. Okay, let's make it cleaner by using the bond. Is sharing one pair, single bond. Sharing one pair. Sharing one pair. That's example 4. Feel free to do it before you see the how it's done. It's good to practice on your own. You pause it and practice. You don't have to wait till I finish everything. This is polyatomic ion. This is nitrate. It has a charge, so it's a little different. So we calculate the total number of valence electron. 1 times 5 is 5. There are 3 hydrogen atoms. Oxygen. 3 times 6 is 18. Remember, step 1 says if it's a cation, subtract. If it's an ion, add. That's 1 negative, so we add. We add. So it's 24 valence electron. Okay, now, which is the central atom? Nitrogen has 3 unpaired, is the least electronegative. Oxygen has 2 unpairs. In case you're wondering what I mean, 3 unpaired, oxygen, and also you can use the electronegativity value to determine that. So nitrogen is in the middle. Oxygen, oxygen, oxygen. We make this octet. We make this octet. We make this octet. Okay. We have 8 plus 8 plus 8. This is 24. 8 times 3 is 24. We have nothing left. So, what do? We have to, they're the same atoms. This is not stable. So that means we can do this. We can move this here, which we give give this. Give this. So we'll have one, they're sharing this one bond, but this is 2 pairs, 2 bonds. Then you have to do this. Okay, one thing with this, if you move this is correct, if you move this is correct. So this is called resonance. So it can be, it also can be this. So it can also be this. So if you get any of these is correct. Yeah. So if you do it this way, this way, this way, either of them is correct. So these are the examples. Now, I have you do the practice questions. Pause the video and do the practice questions. I hope you got this far. This is the answer. The Lewis structure, Lewis structure for these 5 molecules. I hope you learn how to draw it.